Okay, today we're going to talk about angles and the unit circle. So to start off with, I'm going to talk about what the gist of the lesson is. You might not get it all at the beginning, but I will refer back to it, and hopefully as we go forward it will make more sense to you. So to start off with, the measure of an angle in standard position is the input for two important functions, and we're going to talk about those functions later in the lesson. The outputs are the coordinates of the point on the terminal side of the angle that is 1 unit from the origin. Okay, so now let's go define some things about angles so we all know what we're talking about and on the same page. First off, an angle in the coordinate plane is in standard position when the vertex is at the origin and one ray is on the positive x-axis. This ray, the ray that's the positive axis, is called the initial side of the angle. The other ray is called the terminal side. And hopefully you can see initial, of course, is beginning. Terminal is ending. We have different words in your vocabulary hopefully can remind you of that. Okay, so here's a picture of an angle in standard position. Okay, positive x-axis is my initial, I didn't spell that correctly. Positive x-axis is the initial side, and the arrow is showing the way that we're going, the direction that we're drawing our angle, and where we stop is our terminal side. Now, if you notice, we have two different directions, okay? This direction, of course, is counterclockwise, and down here we are going in a clockwise direction. Something to keep in mind, it's opposite of what you think. A counterclockwise actually describes a positive angle, and a clockwise direction describes a negative angle. So keep that in mind as you're going forward. So we have a picture here of an angle, and they want to know what the measure of the angle is. So we're starting at the positive x-axis. Hopefully everybody knows that if we turn face about, that's 180 degrees. And then you can see that if I'm at -2, -2, I have gone to the left 2 and down 2, which means that these two are the same, and this is halfway between, making that 45 degrees. So the whole angle is going to be 225 degrees. Now let's talk about sketching angles. Okay, when you sketch, you have your initial side, 85 degrees. Where is 85 degrees? Okay, we talked about up here, that's 180 degrees. This, of course, is 0. Up here is 90 degrees, and down here is 270 degrees because it's 180 plus 90. Okay, something else to keep in mind too, just to refresh your memory. This is the first quadrant. This is the second quadrant. This is the third quadrant and the fourth quadrant. Okay, so back to drawing an angle. If I have to draw an 85-degree angle, I know that this is 90 degrees, so I'm going to draw a line, a ray, excuse me, close to 90 degrees. Starting at my initial side, I'm going to draw an arrow to the terminal side and label that angle 85 degrees. Okay? -320. Sometimes it's easiest to think of the positive and then just go in the opposite direction. So remember, this is 0 degrees. Well, it's also 360 degrees. So if I start here and I went all the way around, I would be at 360. But I'm about 40 degrees short. So 320 is going to be about there. But I have to go in the negative direction, and I'm going to go 40 degrees short. So I'm starting here, going all the way around. drawing my arrow and labeling it as negative 320 degrees. Make sure you put that degree symbol up there. And last but not least, we have 180 degrees, so we just draw the arrow that shows where we're starting and where we're ending up and label it as 180 degrees. Okay, the next thing about angles that we need to talk about is when we have two angles in standard position, they are coterminal angles if they have the same terminal side. So notice here that if I go from the initial 0 degrees all the way to this is my terminal side, then I'm at 135 degrees. That's my terminal side right there. Okay? And if I went in the negative direction, that would be 225 degrees. So I could also start at 0, go all the way around, but whatever I do, I have to stop at that same terminal side. So if I started with 135 degrees and I went all the way around, which is 360, then another coterminal angle is going to be 495. So this angle with the loop-de-loop is 495 degrees. So keep in mind that coterminal angles is all about adding or subtracting 360 degrees from from a certain angle. Any angle actually. How many coterminal angles do we have? How many times can you subtract or add 360? Infinite. So there's an infinite number. Okay? So which angles are coterminal? If I see one negative, I'm going to add 360 to it. And when I do that, I end up with 45. So that means that these two angles are the same. They're coterminal. They both end up at the same place. Okay? Here's one. If I take 360 away from this, actually, I should do it the other way. I should do it what I had. If I take 360 away, then I would be at negative 45, which is not the same. And if I add 360, then I'm going to be bigger. So clearly, that's not coterminal. And then 405, if I take 360 away from it, then that is 45 degrees. So this is another coterminal angle. So these three, adding or subtracting from the original angle, gives me the same number. Sometimes they give you an angle and ask you to find a coterminal angle. In this case, they want it between 0 and 360. So 385, I'm going to subtract 360, and I'm going to get 25 degrees. So 25 degrees is an angle that is coterminal with 385. That's part of your homework, so I'm not going to do those two. Negative 405, it's a negative, so I'm going to add 360. And when I do that, I'm at negative 45. My directions said to go between 0 and 360. I'm not there yet, so I need to add 360 again. And you'll find out that we are now at 315. So that is a coterminal angle with 405. Okay, now we're going to review a little bit from geometry before we go on to the next big thing of the lesson. Hopefully you remember things called 30, 60, 90 and 45, 45, 90 triangles. Those are your special right triangles that you had. So if you look at this triangle and I tell you it's a 30, 60, 90, hopefully you realize that this is your 30-degree angle. This is your 60-degree angle. And if I tell you the hypotenuse is 1, then you hopefully remember that the short side is half the hypotenuse and that the longer leg is the square root of 3 times the short leg. So that gives us those sides. And if I flipped it around, rotated it, this would be my 60-degree angle. This would be my 30-degree angle. Hypotenuse is still 1, but my short side is half the hypotenuse. Long side is square root of 3 times the short side. And then we have our 45, 45, 90 triangle. Hypotenuse is 1. And some people don't remember, but when you know your hypotenuse, the side times the square root of 2 is how we, excuse me, when you know a leg, a side, you take a side times the square root of 2, gives you your hypotenuse. So if I set up that equation and solve it for x, and then I rationalize it, you'll see how we know that each side is the square root of 2 over 2 and the square root of 2 over 2. So we're going to use this information, and carry it over to a unit circle. So our unit circle, hopefully you also remember from geometry that the equation for a circle is x squared plus y squared. That's if the center is at the origin, which is where we are, and our radius is r squared, and my radius is 1. So what I'm going to do is take those triangles that we just talked about, and you're going to pick up your red pen if you have a sheet and are working along with me, and you're going to, I just want to show you real quick, if I take this red triangle and I put it up here, you will see that's one of our triangles, and it matches up. So what angle is this that we're measuring? This is the short side, that's the long side. So hopefully you realize this is a 30-degree angle. Okay? And some people, well, we'll keep going from there. So it's a 30-degree angle. Remember how my hypotenuse was 1, my short side was 1/2, and my long side is the square root of 3 over 2. So that means that if I have this point on a coordinate plane, then I have gone over that many and up that many, that the coordinates of the point are the square root of 3 over 2, comma, 1/2. Now, what we're going to do is take this triangle, and notice that if I take the triangle and flip it, it slides right in here. So now this same 30-degree angle is 30 degrees before 180. So 30 before 180 is 150. Okay? Now, before I continue, let's review something real quick. Again, we talked about this is our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. What are the signs, SIGN, of the points in this quadrant? Well, if we're in the first quadrant, our signs are always positive, positive. Once we go to the second quadrant, my x becomes negative, but my y is still positive. And when I get to the third quadrant, both my x and y are negative. And the fourth quadrant, I'm back to a positive x and a negative y. Those things will come in handy if you remember them. So if we're at 150 degrees, okay, I got the same triangle. The only thing that changed is now my x is negative and my y is still positive. Now I'm going to go back, excuse me, I'm going to flip the triangle up and down so you can see how it fits right here on my unit circle. So now I'm going 30 degrees after 180, which is 210. Same coordinates, but this time they're both negative. Negative square root of 3 over 2, negative 1/2. And then if I take my triangle and flip it again, left and right, it'll slide right into the fourth quadrant position. And so I now have an angle that is 30 degrees before a complete rotation. So that's 360 minus 30, which is 330 degrees. My coordinates are the same. I have a positive, got stuck on me. So our coordinates, I'm back to a positive x and a negative y. So I'm going to take that triangle back down. Actually, I'm going to flip it one more time. So we'll have it back to, I think I flip it up and down. There you go. Because I had someone want me to write what we did on the other page on this one. So we're going to put our 1, our short side is 1/2, our long side is the square root of 3 over 2. So we're going in order. The next one is a 1, and this is my 45 degree. So that's the square root of 2 over 2, square root of 2 over 2. And then I have my 30, 60, 90 changed a bit, flipped, rotated, square root of 3 over 2, comma, 1/2. So let's go do those and fill in our blanks. So the first one that we have is a 45-degree angle, and it is the square root of 2 over 2, comma, square root of 2 over 2. All right, down to my purple line in the next quadrant. That's 45 degrees before 180. That's 135 degrees. My x now is negative. My y is positive. Down to the third quadrant, 45 degrees after 180 is 225. Both my x and my y are negative, negative, negative. And then in my fourth quadrant, 45 degrees before 360 is 315. And my x is back to positive, but my y is still negative. Okay? I'm going to take these off there. It might be confusing. All right, now let's go on to our next one, which is our 30, 60, 90 just changed. And so instead of it being a 30-degree angle, now I'm at the 60-degree angle. Okay? And the nice thing about this is once you know, if you know 30 degrees is the square root of 3 over 2, comma 1/2, then this is just going to be switching your x and y. So it's 1/2, comma, square root of 3 over 2. Okay? Into this next quadrant, 60 degrees before 180 is 120 degrees. My x is negative, and my y is positive. Going down to the third quadrant, 60 degrees after 180 is 240. Both of them are negative, so I'm at negative 1/2, comma, negative square root of 3 over 2. And then when I go to my last 60-degree angle, these angles are always being made with our x-axis. 60, excuse me, 60 degrees before 360 is 300 degrees. My x is back to positive. My y is still negative. So we have a summary of all of them. We need to go back and name the ones that we've left blank. Those are a little bit easier if you remember that you're on a unit circle with a radius of 1. This, of course, is, we've talked about this. This is 0 degrees. This is 90 degrees. This is 180 degrees. And then 90 plus 180 is 270 degrees. If you remember we're on the unit circle, then, and we know that we're always putting x and then y, we have gone over 1 and up 0. So these coordinates are 1, 0, which makes this one 0, 1. This one over here is negative 1, 0. And 270 is going to be 0, negative 1. I also like to write 360 under here. Helps people remember, because sometimes they forget. Okay, moving right along. I think we have labeled every position on our unit circle that's important to remember. The most important thing to tie this all together is remember back in the beginning, we said the measure of an angle in standard position is the input for two important functions, and the outputs are the coordinates. Well, I'm on that unit circle, The two important functions that we're talking about are cosine and sine. Now, y'all talked about those in geometry, so you're familiar with it. This means that whenever I want to know the cosine or the sine of an angle, all I have to do is go to the coordinates. For example, the cosine of 30 degrees is the square root of 3 over 2. The sine of 30 degrees is 1/2. Okay? Just like x and y are in alphabetical order, cosine and sine are in alphabetical order. So if I want to know this sine of 240 degrees, I find 240 degrees on my unit circle. The sine is the second coordinate. So the sine of 240 degrees is negative square root of 3 over 2. So to finish up our lesson, I'm going to go back and do a few of the last couple of problems that you have, number 4 and number 5. Number 4 says, what is the cosine of theta? Theta is the angle that is often used to describe an angle in standard position. We'll go ahead and write this. This is angle in standard position. And so they're asking us for the cosine of negative 90 degrees. Okay? So if you go back, where is negative 90 on my unit circle? Well, 90 is here, but I have to go negative 90, so I end up down here. So what's the cosine? Cosine will be 0. The sine will be negative 1. So you're going to keep that unit circle handy until you have it memorized, and we'll talk about how to do that. Cosine we said was 0, and the sine is negative 1. All right, and I'm going to finish up with with these two examples because I think you got those. Um, what are the cosine and sine of theta if theta is negative 45? So cosine of negative 45 degrees, and we need the sine of negative 45 degrees. So looking on my unit circle, if 45, positive 45 is right here, then negative 45 is down here. What's my cosine? What's my sine? So let's go fill those in. So the cosine is, not far enough, cosine is square root of 2 over 2, and the sine is negative square root of 2 over 2. Let's go do 150. Cosine of 150 degrees and the sine of 150 degrees. So again, back to my unit circle. Now you know why you want to have it handy or memorize it. 150 degrees is right here. What's my cosine? Negative square root of 3 over 2. My sine is 1/2. So we'll go fill that in. Moving on down. All right, cosine is, we said negative square root of 3 over 2, and the sine is 1/2. Now, I look back up here, this one might be a little challenging. 540, so let's go talk about that one. I think 360 is not so bad. Cosine of 540 and the sine of 540. So the gist of it is you got to find out where 540 is on the unit circle. Well, here's 360. So how much more to get to 540? Okay. So if you don't know, you're going to use your calculator and subtract 540 minus 360. Okay. 540 minus 360 is 180. So we end up over here. So 360 degrees plus 180 gives me 540. There's my cosine. There's my sine. So let's go fill that in, and then we will finish the lesson. Cosine is negative 1. Sine is 0. And we have finished our discussion on angles and the unit circle.